Hello, hi, it's Alex from Blue Lightning Software here. Just carrying on from the last stream of jobs versus tasks. Haven't actually changed the code at all, just changed the names just now to make it clearer that one was jobs and the other was tasks. The tasks were pretty well marked, and the jobs just weren't in the code marked as jobs. And now they are. That's just the only change I've made. And on this screen here, we've got the jobs written there. So no change at all. I mean, I suddenly freaked out at the end of the last stream because I had to be somewhere. And it was kind of obvious that jobs had won by miles. But what freaked me out was the time. What's that saying? When did I change that? No. Hold on. File on disk was. I don't know. I should go to is as long as it's the most recent one. Jobs test, jobs handle. What freaked me out was jobs test runs through. Okay, it calls job method. I removed the timing using any kind of invoked delay. There's no delay to it now at all. What this does, if the counter system was maintained though, so when all the jobs were done, it would go here and complete all on the job handle, complete all of the jobs handles we put together to kind of say that that it all worked. What changed though was that with the way this executes now, this one, the final lap counter. The jobs are still running, the jobs are started, jobs are scheduled. This creates the job and it's scheduled. Now, what this means is the job is running. Okay, job handle, a handle to the handle to that job is then added to job handles. Okay, when the number of job handles is greater than the total, it goes to jobs finished. At this point, it complete all is called. Now this blocks the thread, the main thread at this time, and at this point it puts the timeout to the front. This is where it's all gone a bit wrong because it posts that twice. This is where I was freaking out. Invoke elapsed is not actually. So we were getting the last invoke elapsed. All right. So it's what this means is, okay, this one no longer exists. That number technically for the jobs, anyway, does not exist. So there's like the numbers were kind of mixing up. Whoops. For calls and complete to. Yeah, that is the same number, but it no longer makes sense. That's a shame. Oh crumbs! That's all wrong then, isn't it? Hold on. We don't have a number. Oh gosh, hold on. Yikes. Let's try and work this out before I change that number there. Okay, so let's try and get this. Let's try and lift this out of there and put it's such a weird way of doing it because yeah, you can get that number but you can't get that. You can get both numbers somehow. But it's kind of random as to which No, it wasn't random. Every time it called, it's almost like I could get -1. So it's doing the jobs test, yeah. Once it goes through here, if that counter is jobs finished, it prints this and locked, and then it took the time for the last one. Do you see it took this time there? Okay, that didn't actually practically work. Oh, it should do. No, it should just be that and then this. It's not. It's called jobs finished now. I'll make some weird noises if you can hear those. Jobs finished. We got that time, and then it goes to jobs finished. That should actually work. Unless I got nutty. I'm finding it confusing. I think I'm getting a bit tired today. Job finished is now got both those times, yeah, because it's taken that time. Okay, that was all the calls were made. Ran through here, all the calls were made. Then the jobs finished was called, and it printed both the times, yeah. So hopefully that works now. I mean, it's probably getting a bit confusing with the times route not working. That's when I lost it, I think. So I lost the plot. So let's have a look at that now. It's my first fumble into doing my own jobs for the job system. It's something I'm thinking about doing in Questmaster's Realm, certainly, is to... there's bits of it. I always I never really saw where it would work. I think I'd have to talk in another video stream about how that would fit together. So, wow, I've been put these about 10 times with brain fog. So, yeah, there's like a pattern. I think if I was starting again, entities, component system makes a lot of sense. The way it works when you run everything in parallel. And I almost need to talk about that in a different video. This is task now, which hopefully it's running quite fast. It's running really fast for tasks. 10,000 and 10,000. What's with that? I know what's different. Yeah. Wow. That's wrong. That's got to be wrong. Because this is an asynchronous, all right? No, it just doesn't make sense. You got to take these numbers a bit of a pinch of salt, because this is the complete time. Tasks. Wow, that doesn't make sense. So let's check this. Let's do 100,000, make the math really hard. Quite a lot more math. 5916. I think this is without burst. Yeah, these are proper numbers without the burst. So that's the number it's called all these jobs. Created all the jobs is 3,704 milliseconds. 3.7 seconds, the overhead of calling and setting up the jobs. The tasks, it is telling us for these 10,000 repeat jobs, the task is telling us it's 34 milliseconds. I suppose 3,000. That's actually, now we're getting the proper numbers for task versus jobs in terms of the creation of the jobs. And then the second number is the finishing time, so everything is completed. That includes the initialization time. Yeah, maybe less so with the task because they asynchronously complete, i.e. how much difference does that make? When the it doesn't use that delay task method, calls a separate thread for the math, and it comes back to main thread after awaiting the completion of that other thread. It finishes that task asynchronously completely, and then it calls the counter, and at the end it's all finished. Whereas the job method is adding all the jobs. The jobs test, it calls all the jobs are added, it then finishes that, it then waits, still within this thread, it then goes and waits for this. How much difference is that making? That's hard to factor in, but what it's saying is that's the time, 3.7 seconds, 3,700 milliseconds to create all the 10,000. Let's see if that's scaling right. That doesn't make sense, actually. Do you know why? Because it's almost like the jobs, this affects it. So that's 12,000. The total completion of the work is here. But what I'm seeing with this jobs is this is scaling with the number of... it does make sense. Tasks still going on. Tasks on this 20,000 tasks took ages. Alright, so the jobs won that one in time to complete. 10,000 repetitions of 100,000 iterations. So 20,000 separate jobs or tasks, each with 100,000 iterations. So it is compiling this in a table. Whereas we went down to 10,000, they're pretty much equal. 10,000 jobs and tasks. The jobs one so locks the thread as well, because it's not asynchronous. That wait all is completely blocking the main thread. So actually, I mean, it's almost like creating another thread for the job's completion, just for this example, but I'm not going to go there. But the more the jobs are outperforming the tasks, that was the jobs are definitely outperforming the tasks without, and I think this is without burst compile. All right. So if I put burst compile, it's not even close with burst compile, but let's not add that just yet. Let's decrease the simplicity. Let's not worry about this. Yeah, okay, so we decrease the complexity of the function. Right, this doesn't make a lot of sense. Decreasing the complexity of the function, okay, made the job calls complete quicker. Yeah, so all right, so we double the complexity of the function. It's doing twice as many iterations. Why does that make creating the jobs take longer? I can understand why that would make... so it does all of that. That's just calling the jobs. Yeah. And then it invokes this, which is that first number. Just creating the job, creating a more complicated job and scheduling it. This was weird. All right. Slowed it down. How? I mean, I don't see that. If that was totally asynchronous, it's just set these two, the inputs for the job and fired it off. Why did that slow down the first number, which is the invoke calls elapsed? It calls it invoke calls elapsed. It should be job calls elapsed, but it's that number there. It's not this number. Purely this number here. What is that saying? Is that saying that I can't even figure that out? I can't see why the more complex the function it's calling, the longer the job takes to set up. Just launching the job and moving on, you can see why that would affect the time to complete it. Let's look at tasks. They're just an interesting comparison to confuse everyone. The jobs take ages to set up in that instance, but that's changing with the complexity. That's an interesting factor, that either I've done something wrong or I've logically got it wrong, or something weird happens. But yeah, creating the more complicated job, just scheduling that job, apparently takes longer. Getting the job handle back, it's whirring more furiously. Job's finished. I don't know. I'm not 100% sure how that's taking longer. But it does all add up. And if we add the burst in, let's add the burst back. This will recompile with burst on. It's not even close then. It's just hugely different. But what was interesting there, the calls to these two numbers. Now we've got the right two numbers. These demonstrate the how jobs, the overhead of jobs versus, wow, look at that with burst. And again, with burst, yes, can you see how different? This has freaked me out the last time also. The numbers make sense, but again, the complexity, now it can handle any kind of complexity, but it is, can you see how it dramatically dropped the creation time? There's something about jobs, complexity and speed of running that affects them being set up and scheduled. That's definitely there in this example test. Tasks will take forever with that kind of complexity. They're not even going to be close. The second number for tasks is going to be huge compared to that one. Yeah, it took it 10 seconds. Jobs with burst took it 0.6 seconds. But again, the tasks were created more quickly. That's the interesting thing. There was another thing I considered, is that this job doesn't have an output. Does that affect it? Right only. Okay, so what if at the end of this I said output 0 equals X? I don't think I can. X isn't stored, is it? Float X. Yeah, equals X. Okay, so it's stupid and it's not doing much. All right, don't declare it twice. But what that's doing is posting a result. Doesn't like the output native array, doesn't like X unassigned, so you do have to initialize it. It's interesting. Some of the compilation actually of the jobs is it's interesting. Sometimes this lets me off in the other scenarios. Let's have a look anyway. So we've definitely set an output, so those jobs aren't complete. I don't know if that makes any difference. If Burst looked at that and said, oh, I don't actually need to do anything, so let's just not do anything, because it doesn't have to write a result. I mean, if it's the cleverest compiler alive, it would look at that and say, oh, wow, we don't have to do anything. Oops. Output has not been assigned or constructed. Oh wow, because we didn't assign one, so now output had to be actually written. Okay. And then we would put, doesn't actually need to be initialed. Which is which? So yeah, this is my... so I'm a bit slow. I'm really brain foggy. I don't know why. So yeah, just be here. Job dot output equals output. Okay, so that was assigned. It doesn't like it at all. What's up with that? Can I implicit it? Because that one's an int. Oh, I get slow with these today. New native array float. Okay. So this is just to test if that made it, because it's quite possible that the compiler looked at it and said, I don't need to do anything, why even run it? And did that. So let's have a look at that. Keys breaking. This is my bad. I don't quite understand how it works. You're trying to complete with writes to the same native array. That's the other one. Oh wow, yeah. So it doesn't make sense now, does it? Because well, that's annoying. Because it's the read-only ones were allowed the same output. That's probably why I didn't bother with it actually. But here we go. Okay, let's act like we care. Let's go to job method. Let's try and trick it so it's just doing something. Allocator, I think .temp job is all we need for this. So we're pretending that we care about the output. As that totally wouldn't make sense. How that was set just didn't add up. The read-onlys can be persistent kind of arrays that you use for all of them because they're inputs that are read-only. There we go. But this one is, wow, it's still unbelievably quick. I don't know if that made any difference. It is shockingly close. I mean, what it's saying is the calculations are just being done almost instantly. So that's with burst. But some of that is reflected in the setup time. Do you see what I mean? Some of it is reflected in the that first number. I'm struggling to explain that the call to schedule is influenced somehow by the time of this completing. All it's doing is creating a job handle, putting that job handle in a native array, and doing it again and again. And it doesn't go and look at that until job's finished after this first time is taken. That first time is purely the call time, the job scheduling time. That's what I'm saying, that the job scheduling time is definitely influenced by this complexity of the job to be scheduled. And then the rest of it, the actual execution time is incredibly quick. That's what's interesting. I mean, it's absolutely killing tasks at this point. With burst on, it's not even close. It's not even close on any way. That overhead of creating a task, I don't know if it was really simple. So it's unmissably simple. No, because the simplicity affects it. So tasks will stay the same, that first number. Job's not really changing on that kind of simplicity. But there we see, that's about where the actual scheduling time, weirdly, the only weird effect, that actually gets higher than the task scheduling time, around that level of 10,000 iterations, because the complexity of it somehow affects the scheduling time. So that's the interesting take. I mean, tasks is not worth, I can see why people use jobs. That was really easy in 2 sessions to create a job, simple though it is, to put that in a job and call it like this, and then just run it for loads of things. And it's, once you put the burst on, it's not even close. I mean, it's nowhere near. It's like 10 times quicker just because of burst. What if this was doing it 100,000 times? This would take forever on the tasks, right? Did it let me call tasks twice? This computer's exploded. Jobs make sense. Tasks don't. What's up? Oh no, there it is. Tasks are working actually. Oh wow, I pressed it too many times. It's gone insane. It was so unlocked though. The asynchronous nature of the task just let me press it loads of times and do this. So it's gone insane now. It's running about a zillion tasks. Oh, there we go. Anyway, is that the correct number? That was 100,000 really complex ones. Not that complicated. Just wait for it to finish. It's because it's always got that control on the... That's so weird. Right, can you see? This is where I freaked earlier as well. With a huge repeat number like 100,000, the complexity of the scheduling, you see the scheduling to the completion. I think what it is, what I'm struggling with, they've completed by the time they've scheduled. But also, I think if you look through this stream video, you will see that the complexity is indeed affecting the scheduling time. And the two are more or less, it's more or less finished by the time it's all scheduled. So weird effect, such a weird effect. That, I mean, they're obviously 10 times quicker overall, but the way, you know, that's just an interesting odyssey to think about, that the schedule time, it's almost done by the time it's all scheduled based on the complexity. Like if we doubled this, it's going to be 2 seconds-ish. Yeah, I mean, the two are coinciding now. So it's almost done. It's almost done by the time it's scheduled, and that is heavily affected by the complexity. So maybe it makes sense of it later. But you know, that's an interesting feature. Obviously, 10 times quicker than tasks. Mainly, well, not all because of burst compile. I think they started outstripping at a certain point anyway, and then burst just made it much better. Could be going through this forever if you want, but a quick recap before I finish. This is the burst without burst. Just giving some of what we've learned just now. It's alarmingly close without burst, actually. Do you see the task? If it wasn't for burst, you could have argued about tasks, particularly the time of creating them. You really could have argued were it not for the burst. Actually, I saw there's some combinations of the number of repeats and the... Wow, so that's 20,000 iterations within 100,000 tasks doing the same, 20,000 each. This is the jobs. Oh, and again it's slow and it's more locked up. It's just the way I've done it. I didn't quite async it in the same way. We could have set up a task. Sounds weird. We could have set up a separate thread in a task to monitor the jobs, and that would have made more sense. We would have unlocked this jobs. We could have had the jobs being waited for in a different thread, if that's possible, given the API of Unity. Which is another thing to test. I could test that quickly. It would probably completely explode, but it's an interesting one. Probably not meant to. I can this part here, the jobs handle in the jobs finished. This job handle complete all does that's Unity API, right? To the point that you couldn't run that in a task. You'd have to put that back to the main thread and wait for it. So when it's running a load of work, all right. So, oh wow, that's an odd one. Just in terms of waiting for it to complete with an unknown time, tasks could actually more asynchronous, be more asynchronous in that sense, and not lock the main thread. Given that, although it doesn't make there's probably a way around that. Anyway, that's an interesting look. That's without burst. It's 10 times quicker with burst. That's where it really kills the tasks. So anyway.